Today we're talking about real life examples of growth and decay with exponential functions. So growth formula is y equals a parentheses 1 plus the rate raised to the x. Now, a is our initial value, just like it has been, like we just saw in that painting problem on your homework. The 500 was the initial value. R is our rate. We will be converting it from a percent to a decimal. Decay works the same way, but instead of adding to the 1, we are going to be subtracting. We're getting rid of some things, killing them off. Let's jump right into number 1 about bacteria. A dish has 212 bacteria in it. The population of the bacteria is growing by 80% every 2 days. How many bacteria will be present in 4 days, 8 days, 11 days? First question, are we growing or decaying?
Growing.
We are growing. So,
Does that mean on it or in it?
what do you mean? We have bacteria growing, so we're growing like strep bacteria or E. coli or something beautiful like that.
What's E. coli?
It's bacteria. What is our initial amount? What are we starting with?
212.
What is our rate of change?
80%.
80%, so we're going to make that into a decimal.
Okay.
0.8, you can put the 0 on the end if you want.
Would the X be 2?
No.
Or before?
It's growing, no, just a minute. It's growing every 2 days. So it takes 2 days to complete one cycle. So in 4 days, how many cycles have been made?
2.
Because you did 4 divided by 2. In 8 days, how many cycles have happened?
4.
Because you did 8 divided by 2. In 11 days, how many cycles have happened?
5.5.
Because you divided by 2. So our x is going to be whatever it is divided by 2. A little funky there for our exponent, but it'll be okay. So to our handy dandy calculator we can go, and you're going to simply replace the exponent with this 2 that we just found, or the 4, or the 5.5. So I'll show you with this one. I'll give you a second to catch up on the writing. Yes.
So for, you see how the second equal sign?
Here?
Yeah, you just
Okay.
you have 1 plus 0.8.
Yep, so I just combine those. 100% plus 80% is 1.8%. Yeah? Yep. Perfect. So to our calculators we go. Let me get to a better spot. So 212 parentheses 1.8.
686.88. Is that right?
Yep. So after 4 days or 2 cycles, our bacteria has grown to 686.88. Now a scientist will be growing this bacteria, so we will include the 0.88. Mrs. Inslee probably would make it round up to 687 because not so much of a scientist.
So keep
But
the decimal.
Yep.
So they stopped it at a certain point right before the last one
was complete.
What about the other ones, because they get longer? Sorry.
Oh, yeah, that's.
What?
It should be 1 plus.
That's okay, I just added them together.
Oh, I did that.
Okay? Now, I'm going to be a little lazy and not have to retype. I'm just
That's
going to
what
go
I did.
second enter and change this 2 to a 4. You certainly can retype. That is completely legal.
Do we keep all the decimals on this?
I'm going to keep all the decimals on there.
The next one's really.
And then I'm going to again, whoops. This one has a repeater decimal. So the 5,374.4, you can write just one of the 5 sevens and then put the repeater mark over the top of it. You don't have to continue writing 575757. How's that for our first growth or decay problem? Great. Number 2. A house down your street has termites in the porch. The exterminator estimates that there are about 800,000 termites eating at the porch. He said the treatment that he put on the wood would kill 40% of the termites every day. How many termites will be eating at the porch in? Now, note, these are not done in order, okay? I went 3 days, 36 hours, which is less than 3 days, and then I went 2 weeks. So just don't panic when your numbers don't quite make sense.
This is a decrease, right?
This is a decay problem, right? We're trying to kill off those termites. What is our initial amount of termites? 800,000. Be sure you get enough zeros there. Not only when you write it, but also on your calculator. That's a wonderful place to make a mistake. Okay, yep. 40% is a 0.4. So we do. So I actually did this subtraction here. I did the 1 minus the 0.4. So this is going, they're going to die off every day. So this is 3 days, so that exponent isn't going to change. How many hours is, or how many days is 36 hours?
2.
Like 2.5.
A half.
Right.
No, maybe not, just 2 days. is
There's
48
24 hours in a day, so it's
A day
1.5 days. If you did that division on your calculator, it'd be 1.5 days. How many days are in 2 weeks?
14.
So that will be our exponent when we get there. Ready to go to our calculators? $172,800 termites after 3 days. When we get some decimals, again, Mrs. Inslee would say yes, round, because you can't have parts of a dead termite. But the scientists are gonna say don't round, because that gives us a better picture of what's happening with.
So do I
You're a
listen to the
scientist.
scientist or do I listen to Mrs.
Always listen to Mrs. Inslee,
Okay.
even if
Well,
the scientist is in the room,
Termite's
always.
leg is like still touching.
Yeah, exactly, still alive.
Not very long.
Right.
It's not very
So after 14 days, are the termites gone?
No.
There's significantly less of them. After 2 weeks, there's only 627
Out of 4 or 3, whatever.
out of 800,000. So you're not
This is
gonna be
crazy.
seeing them for sure.
No, now they'll just give your name report.
This one's mine, so it makes sense to her. Okay. Ready to move on? Some of you are still writing.
The little packet.
Did you all do mealworms in like 5th or 6th grade?
Oh, God,
Yes.
no, what is
Even
that?
for
What
fifth
are
grade.
I have to eat them.
Mealworms.
In number 3, seriously, a 5th grade class started out with 10 mealworms for an experiment. The population of the worms will double every month. How many mealworms will the class have for their experiment in? And again, I didn't put these in numerical order, so when your numbers are different, don't panic. This time, are we growing worms or decaying worms? We are growing, so it will be a 1 plus in our equation. What do we start with? Our initial value is 10. What's our rate?
100%.
It's 100%, so it gets added, another 1 gets added there. So when we simplify our growth function, it's very simple. And this is changing every month.
Miss Inslee,
Yes.
for, the 45 days one, what did you just 14?
It's a month and a half.
I mean,
Would it
one,
be
wow, I'm done.
0.
So there's 45 days and there's 30 days in the month of June, so it's 1.5 months for the exponent for 45 days. And again, the scientists would tell you, keep those decimals because that's the most accurate representation. Mrs. Inslee is saying you can't have part of a mealworm.
We said that the scientist is saying that they can't be part of it, right?
No, the scientists would say, keep those decimals.
The scientist wouldn't.
But real life would say, no. So when they come back to school in September, at the end of 3 months, they're gonna have 80 mealworms. A year later, when they're sixth graders in June, they have 40,960 mealworms. And their science teacher who comes back in to check on the mealworms in the summer is gonna find about 28 mealworms.
So they,
No, remember I put these out of order.
oh, yeah.
That's why our numbers don't go in correct order. How are you doing with growth and decay problems?
Setting them up.
Setting off is the hardest part. So far, knock on wood, they have, on the Regents, given you the equation. So you don't have to do the setup part. But, now that I've said that, they won't do that this year, and you'll have to set it up. So I'll feel better.
Say something.
Let's do number 4. Your baby brother has been diagnosed with an ear infection. The doctor says there's probably, what's that number? 50 million bacteria in his poor little left ear. Tiny little buggers. The penicillin the doctor prescribes is going to kill 7% of the bacteria every 6 hours. Hold on, think about that. You can make them all into hours, yes, that would be fine. How many cycles is that penicillin going to kill over the course of one day? 4, right? Because there's 24 hours in a day. So it's 4 cycles. 4 killings, if you will. That doesn't sound very nice. So if it's 5 days, how many cycles would
Is
that be?
it 96 or 1?
Yeah, 20, yeah. So we've got 2 ways to do it. We could do 5 times 24 and get that that's 120 hours. And then 120 divided by the 6 cycles every hour tells us 20 cycles. Or just 5 times 4, because we know how much it is for each day. Yep, a couple different ways to go there. A week is going to be 28 cycles. 1.5?
No, I just put 0.5.
0.5. Is that what you said, or did I hear it wrong?
I said 1.5.
Okay, so 3 hours is half of the cycle. And again, no, these are out of order, so don't panic when your numbers are lined up sort of incorrectly. What does our exponential function look like?
I don't
Y
put
equals
this
6.
part.
Let's see, 1 minus 0.07.
Is it the 50?
Close. We need to
million?
start with our initial value, so how many bacteria are in little brother's ear? Okay, and
it's
then-
an increase.
are we killing or keeping? We're trying to
Killing.
decay, we're trying to get rid of them, so it's 1 minus
1 minus
the 0.7, and our time has to be divided by 6, which we already did.
It'd be 0.07.
Thank you, it would be 0.07, thank you very much. So,
So So what about the x over 16?
The x over 6 thing we already did right here when we figured out how many cycles
Oh.
it's going to go through. Okay, but in our formula, we would still write it. Okay, to the handy dandy calculator we go. Remember, these are bacteria in your brother's ear. So the scientists are going to say, don't round. And the math teacher is saying, but it doesn't make any sense. Okay?
Darn it.
Good, let's talk about number 1 on your homework, please. Number 1 on your homework, please, wants to know if this equation will ever cross the x-axis. So it wants you to graph it, and then it wants to know will it ever cross the x-axis. Okay? No, it doesn't cross the x-axis when you graph it. 2 to the x goes like this. The question is, as it trails off here, does it end up going below the x-axis?
So I figured that out.
Okay? Well,
Yes. it
okay.
Well, just
Go to
stop.
the table.
Remember that that x is an exponent.
does. It's not your recording.
Yeah? So as we go down in our exponents, we keep getting smaller. This question is saying, what exponent can you get to 0? And the answer is none.